Hello everyone, welcome back. In this episode, we are going to implement a FPS counter and our little stress test. Then we see how much FPS we get out of our small optimization by using bounding boxes versus without using bounding boxes. Our current state is we have our bounding boxes, they're intersecting, they are already doing its optimization part. We also, I hope at least, we're gonna see our collision drawing. I think I know why we don't see it. All right. Yeah, let's jump back to the code and fix some things. Good. First of all, in the main HTML, I'm gonna move that clear method before the update. Okay, and then after the clear method, I'm gonna calculate our FPS, and that's really simple if you have the delta time, because this is just well, of course we need to declare a variable first. This is just the delta time divided by 1. 1.0 divided by delta time. That's the right approach. And then we're gonna say FPS. Of course, you don't need to add that string, but I'm gonna use it. I'm gonna do it. There you go. All right, then we have the delta time text, and then we're gonna draw it using draw utils. Draw text. Then I'm gonna say new vector at position 10, 20 with the size of 12, a color of black, and then the delta time text. All right, and then we can jump back to the browser and refresh. There we go, we have our FPS, though it's a little bit unreadable. We will change that in a second. And also we are seeing our collision information now. Pretty cool. Okay, so let's just fix our small problem with the FPS counter. Go back to the code, and this fix is also pretty simple. We're just gonna round this value to 2 numbers. That's it, math.round. Then if we go back to the browser and refresh, we're gonna see 60 FPS. And sometimes it's dropping below it. And yeah, that's everything. Now I guess we can create our little stress test. And for this, we're gonna create a small pyramid. So go back to the code. Then we're going to the simulation class, and we are creating a new method under the, or let's say above the create boundary method. And I'm gonna call this one create stress test pyramid. And we are going to use this stress test also in the next couple of episodes, where we're gonna see how we can do a spatial partitioning and a spatial partitioning using hash values. So let us first define a box size. So how large will our boxes be? Okay, then we need to set a iterations variable. You're gonna see why we need that. And then we say top offset. And this is the world size minus iterations times the box size. This basically means the top is at the bottom of our rectangle, for our canvas. Okay, the really top is at the bottom of our canvas, and from this one we want to set the pyramid a little bit to the top, so it's not intersecting with the bottom. And iterations is used to create our boxes. So do that for again, then I smaller than iterations, I plus plus. Then we can say again a for loop. Also, this will be iterations. This one is greater than iterations minus I, because this will create our rectangle of boxes. It does look a little bit weird, but this is just for testing purposes, so you don't need to know really how it does work. But of course, just change the values and you know what will going on here. Then we need to calculate the x position, and this is the box size times y plus y. Okay, will be a little bit complicated. Box size divided by 2. And the y position is just box size times, yeah, this one. Then we can say this dot rigid bodies dot push. So new rigid body with a new rectangle with a new vector 2 at position x and y plus top offset. Then we have the box size. The height will be box size 2 and a mass of 1. Okay. Then I'm gonna remove, or I'm just gonna comment the other lines out. And I'm gonna call this one too. And I'm gonna call this dot create stress test pyramid. All right, then let's jump back to the browser, refresh. And nothing works, seems like. All right, let me check what's wrong and I'll be back. Right, yeah, I made a small mistake. We need to change this variable to minus minus, okay? Then we can go back to the browser. I'm gonna refresh, oh yeah, to the browser, and this is our little pyramid. Of course, there's a lot of information drawing on here. I think I can just comment these things out. So let's just say collision manifold to draw. We don't want to show this one, and I think we also can remove our drawing for the bounding boxes. So for this we need to go, I guess, for in the rigid body class to the drawing, if there's a drawing. Where did I draw the rigid bodies? Ah, okay, yeah, in the shape, of course. Okay, and here we have our bounding box. Disable this one. I'm also gonna disable drawing the centroid. Okay, refresh, go to the browser. And there we go, that's a little bit better. We still have the collision manifold drawn. Okay. Also the normals. I don't want to draw the normals too. So I'm gonna do that too. Yeah, I'm gonna look around what things I want to disable drawing, and then I'll be back again. Okay, I found now everything. Let's go back to the browser, and first I forgot to remove this draw util draw arrow in our collision manifold, so remove this one. Then I want to, I don't want to display our normals, and we can do that by going to the polygon glass and disable this draw line here. And now if we go back to the browser, we should see, if I refresh, if it should work. Come on. There we go. We have our simple rectangles without information. And you can see here the rectangles are sliding from each other. And we can also increase our pyramid. Let's just first increase or make our pyramid greater. We can say with the iterations here, we can say, let's for example 10. And with 10, we're gonna increase our pyramid by 10 blocks in the height and in the width. Okay, then let's go back to the browser, refresh. There we go, we have our pyramid. Here you can see the rectangles are penetrating each other. And we can solve this by using a solving iteration or iterator. That means we are just doing our calculation here in the update method multiple times. So what do I mean with that? We are just using a loop, a for loop again, and we're going to iterate over these where we're doing the collision step here. Okay, so let's move this whole pack here and add a new for loop. And here I'm going to say let solver iterations is equal to 0. Solver iterations is less than, let's say, 20. And solver iterations plus plus. And then we need to add some curly brackets. There you go. You can also add 10 or 5. The higher the number, the stable it will be. So let's jump back to the browser and see how it looks now. There we go. It's way, way stable more now. It's still sliding though, and it's still, in some time, it will collapse again. But I think for our simulation, that's fine. Okay, now we can increase our pyramid. I think I'm gonna say, I'm gonna set the iterations to 25 now. There we go, and refresh. And now you can see the effect again. If we add more and more and more boxes, it will just collapse. And then, of course, we need to add the solver iterations to a higher number, and then it's going to be more stable again. So I'm going to say now 50, and let's see how it looks. Go back to the browser, refresh. Now it's, well, yeah, of course, the delta time is now higher. That's why it's going to be more inaccurate, because we're losing FPS. That's why it's getting unstable. What I'm gonna do now is I'm gonna set a fixed delta time. I'm not using the delta time calculation here anymore. I'm gonna use a fixed delta time of 1.0. And for this, I'm gonna pass the delta time. Where do I pass it? I think Yeah, I'm just gonna pass it in the rigid body updates method. Like right here, I'm gonna say a fixed data time of 1.1. Let's refresh this one again, and now it should be a bit more stable. Well, it isn't really. All right, I changed the number. I put an even lower number to it. Now it's 0.01. Yeah, and now you can see it's way more stable. But let's just change this iteration, the box size of it, to 10 again, and use the delta time for now. And I'm gonna change the solver iterations to 22, to 20 again. Go back to browser, refresh. Oh, I changed the box size and not the iterations. So iterations to 10 and the box size to 25. All right. So again, back to the browser, refresh, and now we have our boxes. We still have 60 FPS, and now we're gonna disable our check for bounding boxes. See, we have 60 FPS with bounding boxes. Now we're not using the bounding boxes again. So I'm gonna just comment these 3 lines here out. There we go. Go back to the browser and see if we have a FPS impact. And there we go. We have literally nothing. Oh, and it's because the colliding method variable is not defined in simulation 65. Okay, and that's alright. Yeah, I did a small mistake. Sorry for this. So let's just comment these things too. Then refresh. Okay, we have still 60 FPS. Then let us just increase the number. Okay, let's say I'm gonna say 15. Refresh. Now we have 30 FPS. As you can see, we have 30 FPS. Now 50. But if I refresh, you can see 30, 20, 30. Yeah, and it also saying the request animation frame took too long. And now I'm gonna add the bounding box check again. So I'm gonna say this one, this one, this one. Go back to the web browser and refresh, and we have stable 60 FPS. So it's doing a lot of optimization for our simulation. And this will be even greater if we implement our spatial partitioning techniques. All right, I think that's it for this episode. Yeah, in the next episode, I'm gonna explain how a spatial partitioning is working. And then we're gonna implement the spatial partitioning technique. After this, I'm gonna explain the spatial hashing technique, and then we're gonna implement this one too. And then we are going to our joints. Alright, hope you had some fun, and sorry for my small mistakes that will always happen in my tutorials. Yeah, sorry for this one, and see you hopefully in the next episode. So, have a nice day, and yeah, bye bye.